When Spark processes data, it tries to keep everything in memory because RAM is fast. But when the data becomes too large and memory starts filling up, Spark needs a backup plan. That backup plan is called disk spill. Disk spill happens when Spark temporarily writes part of the data to disk so the job can continue running instead of failing. In simple words, when memory says, "I'm full," disk steps in. Disk spill usually happens when the workload is larger than the available executor memory. This can happen with large data sets, big joins, aggregations, sorting, or shuffle operation. Spark prefers to use memory first, but if the intermediate data does not fit in RAM, Spark moves the overflow data to disk. This happens automatically, so you may not always notice it immediately. But behind the scenes, Spark is saying, "I cannot keep everything in memory, so I will spill some data to disk." Disk spill slows down Spark jobs because disk access is much slower than memory access. RAM is designed for active computation and fast data access. Disk is designed for storage, so reading and writing data takes more time. When Spark spills data, it must write data to disk and later read it back when needed. That extra disk input and output adds waiting time, reduces performance, and can make a Spark job feel much slower. So, the more spill you have, the more performance you can lose. In Spark's execution plan, disk spill can appear during expensive operations like sort, join, group by, distinct, and repartition. The flow is simple. Spark starts processing data in memory. If memory becomes full, Spark spills part of the intermediate data to disk. Later, when Spark needs that data again, it reads it back from disk and continues the computation. Disk spill is not always an error. It is Spark's fallback mechanism when memory is not enough. But too much spill is a warning sign that the workload may need optimization. A common example is using the memory and disk storage level in PySpark. With this option, Spark tries to cache the data frame in memory first. If the entire data frame does not fit in RAM, Spark stores the remaining data on disk. For example, you can see the code in our conversation history. This tells Spark, keep the data in memory when possible, but use disk as a fallback when memory is not enough. It is useful for large data sets, but remember, data served from disk will be slower than data served from memory. Here are the key takeaways. First, Spark always prefers memory because it is faster. Second, disk spill happens automatically when memory is not enough. Third, disk spill helps the job continue, but it can make the job slower. Fourth, watch out for heavy shuffles, large joins, big aggregations, and poor partitioning because they can increase spill. And finally, monitor spill, tune partitions, optimize joins, cache carefully, and reduce unnecessary data. Less spill usually means faster Spark jobs. Keep your data flowing, keep your memory healthy, and keep your Spark jobs fast.